So here's this problem. I'd like you to read it first, and then we'll read it together. All right, so Rick wants to travel from Skyline to his niece's house in San Leandro. The speed limit on the freeways is 65 miles per hour, and on the Bay Bridge is 50 miles per hour. The Bay Bridge is 4.5 miles long, and the distance he needs to drive on the freeways is 30.1 miles. First part is how much time to the nearest minute will it take to drive if Rick drives exactly the speed limit? And then a follow-up, how many miles per hour over the speed limit must he drive to cut the time to 30 minutes? The implication being that in part A we find something a little bit over a half hour. So as we start going, we're going to use the formula that the distance traveled is just how fast you're going times the number of hours that you're traveling that way. So the distance is rate times time. And when we solve that for time by dividing by r, we get time is distance over r. So I start to figure out the time in hours it's going to take to go over the bridge, and I look at it and I get 4.5 miles over 50 miles per hour. With the calculator, I come out to 0.09 hours, so it's not much time, really. And if you think about it, if there's no traffic on the bridge, it does go by pretty quickly. But then on the freeway, we're going to take a little bit more time. It's 30.1 miles, and we're going a little bit faster, but not much faster, and come out to 0.4631 hours, which is almost a half hour. Putting those together, getting the time on the bridge plus the time on the rest of the freeway, adding those two numbers together, and we get 0.5531, which is just over a half hour. What we want to do is look at what this is in minutes. And so we're going to have to convert that 0.5531 hours into minutes. And so we know that 1 hour is equal to 60 minutes. And so we're just going to see how many times do we have 60 minutes. Well, a little over half a time. So 0.5531 times 60 gets us approximately, if you round off to the nearest minute, approximately 33 minutes. Moving on to part B, we go, okay, so how many miles per hour over the speed limit is he going to need to drive to make it 30 minutes, to cut that by 3 minutes? And we start off by letting x be the number of miles per hour over the speed limit, so that it keeps track of how many miles per hour over the speed limit. And we're going to assume that whatever you calculate here, you're going to go that many miles per hour over 50 when you're on the bridge, and you're going to go that many miles per hour over 65 when you're on the freeway. So that 4.5 miles over the bridge will be traveled at a rate, and so there's a typo in there, sorry about that, will be traveled at a rate x miles per hour more than 50 miles per hour, or x plus 50. And then the 30.1 miles on the freeway will be traveled at x plus 65 miles per hour. Recalculating these times, it's still going to be time is distance over rate, but we've changed the rates. They're no longer 50 and 65, they're a little bit faster. So recalculating 4.5 over x plus 50 plus 30.1 over x plus 65, we get a slightly adjusted expression for the total time. Now we want this to be a half hour, since we want to make it in 30 minutes. So essentially what we have to do is solve for what number of miles per hour over the speed limit, what x makes this equation true. And so that's what we're going to start doing. So looking at this equation, we need to clear out the denominators. So we're going to multiply both sides by the only factors that are in these denominators, the x plus 50 and the x plus 65. Both sides are going to get it, but on the left, it's going to clear out the denominators. In the first term, the x plus 50 reduces, and you get 4.5 x plus 65. In the second one, the x plus 65 reduces, and you get the 30.1 times x plus 50. On the right, there's nothing to reduce, so you get 0.5 times the product of those two binomial factors, and x plus 50 times x plus 65 is x squared plus 115x plus 3250. And so those orange arrows are implying that we're going to distribute next. We're going to distribute those outside 4.5 times x and then times 65, and the 3.1 times x and then times 50, and the same on the right-hand side. And when you do that, using your calculator to do the number crunching, you get 4.5x plus 292.5 plus 30.1x plus 1505. And then on the other side, you get 0.5x squared plus 57.5x plus 1625. We probably aren't going to be able to factor anything. Certainly the square root property won't apply here unless we want to complete a square, which I don't think we do. So we're going to go for quadratic formula. So I still need everything to be on one side and a 0 on the other. So I'm going to start subtracting all the terms on the left from both sides. So there aren't any x squared terms, so I'll just have 0.5x squared. But the x term, I've got the 57.5. I'm going to subtract the 4.5 and the 30.1, and similarly with the constant term. So I end up with 0.5x squared plus 22.9x minus 172.5. And so I have my a and b and c for quadratic formula. Looking at what the calculator gets, I get 6.586 and negative 52.38, which spider senses are tingling. I'm going to toss out that negative number. I don't want to drive backwards, and what would that even mean? And so I'm going to have to drive 6.586 miles per hour over the speed limit to cut my time down by 3 minutes. And so then the question becomes, all right, 6-7 miles an hour over the speed limit, probably get away with it. Sometimes traffic flows that quickly. But for 3 minutes, and you can imagine if you're trying to cut your time by even more, you're starting to drive really crazy fast. And so the question becomes, if you're really not cutting your time by that much by speeding, is it really worth it?